Okay, so this is Algebra 1, Lesson 9.7. We're going to look at solving quadratic equations by using the square root property today. So let's do our warm-up. First, we need to find the square root of the following numbers. That means what number, when I multiply it by itself, will I get what's under the square root? So for this first one, the square root of 36 is 6, because 6 times 6 is 36. The square root of 121 is 11, because 11 times 11 is 121. The square root of 625, that is 25, but I have this negative outside, so my answer is negative 25. And then for this one, we look at taking the square root of the top and the square root of the bottom. So the square root of 4 is 2, and the square root of 25 is 5. So my answer is 2 over 5. Okay, the next one, they want us to solve the equation. So we need to solve for x. So we're going to divide both sides by negative 6. And then we'll get, I'm going to write it up here. Negative 60 divided by negative 6 is a positive 10. Okay, to get rid of the 1/5 next to this x, we need to multiply by 5 over 1. So instead of dividing by a fraction, we multiply by the reciprocal. So 16 times 5 over 1 gives us 80. Over here, I need to move this 40 over first. So if you wondered, I added 40 to both sides. And then I'm going to divide by 2. Move down. Ooh, I went way too far. Sorry about that. Okay, so when I divide 40 by 2, I get x equals 20. Okay, and then for this last one, I'm going to divide by 5. And you can just leave this as a fraction as 3 over 5. All right. So moving on. We're going to look at solving quadratic equations by using square roots. Some quadratic equations cannot be easily solved by factoring. So in the last lesson, we looked at factoring and then setting those equal to 0 to get the x values. With square roots, we can use them to solve some of these quadratic equations. And just recall from lesson 1.5 that every positive number has 2 square roots, one that's positive and one that's negative. So let me show you. For example, I know that 3 times 3 is 3 squared, which gives me 9. But also, negative 3 times negative 3, which is negative 3 squared, gives me 9. So the square root of 9 has to be both the positive version of that square root and the negative version. And when you take the square root of a positive number and the sign of the square root is not indicated, you must find both the positive and the negative. So what we do is we use this, it's called a plus minus sign, and we should put that out in front of whatever the square root is. So the square root of 9 is plus and minus 3. So we could either write it as 3 or plus 3, but we just use the symbol plus minus 3 to indicate it's both positive and negative 3. So again, the expression is read plus or minus 3. So let's look at an example here. If I had a quadratic equation, ax squared equals a, we would take the square roots of both sides. So over here, I would take the square roots of both sides, and my answer would be x equals plus or minus the square root of a. So the only way to get rid of an x squared is to take the square root. And so if I take the square root of both sides, that's going to give me a plus and minus square root of 15. And you can leave it, if it doesn't simplify any further, you can leave it as is. So let's look at this example. If I have x squared equals 169, the only way to get x by itself is to take the square root of x squared. But if I do it to one side, I have to do it to the other. The square root of 169 is 13. But again, we said we have to do the plus and minus. So the solutions are positive 13 and minus 13. Okay? So let's look at this one. If I have x squared equals negative 49, I have to take the square root of both sides. All right, there's a little problem here. What number, if I multiply it by itself, gives me a negative 49? Well, you might be thinking, oh, 7. However, if I multiply 7 by 7, I'll get a positive 49. And if I multiply negative 7 times negative 7, I still get a positive 49. So there is no number that will give me a negative. So there are no real solutions to this one. So you cannot take the square root of negative number at this time. We haven't learned about imaginary numbers yet, and we'll talk about that later. Sometimes, pay attention, if necessary, we want to use inverse operations to isolate the squared part of a quadratic equation before we take the square root of both sides. So you want to get the squared part by itself before you take the square root. So on this next one, the x squared is not by itself, so we want to move this 7 over. And if we move it to the other side, we're going to have 0 over here, which is fine. Now we need to take the square root of both sides. Well, we could write plus or minus 0, but we know 0 only has one value, so the answer is just 0. Okay, so 16x squared minus 49 equals 0. So again, we want to isolate just this x squared. So first we're going to move the 49 over. So we get 16x squared equals 49. Then I want to divide by 16. So you're trying to get this x squared by itself. Don't worry about simplifying this right now. Here's why. I know that 49 and 16 are perfect squares of numbers. So when I go to take the square root of them, I'm actually taking the square root of 49 and the square root of 16. So my x is equal to plus or minus the square root of 49 is 7 over the square root of 16, which is 4. So my solutions are plus and minus 7 over 4. So I would not simplify your fractions at this time unless it's going to help when you go to take the square root. When you're solving quadratic equations by using the square roots, you may need to find the square root of a number that is not a perfect square. So you might take a square root of like 27. In this case, this is going to be an irrational number, and we can approximate the solutions, but since you guys don't have calculators, I want you to leave them in simplified radical form. So what does that mean? Okay, if I have x squared equals 15, the x squared is by itself already, so I can take the square root. Now, there is not a perfect square root of 15, so we would just write our answer as x equals plus or minus the square root of 15, and you're done. For this next one, I'm going to isolate the x squared by moving the 90 over. Then I'm going to divide both sides by -3 so that I can get rid of the -3 over here. Negative divided by negative is a positive, and 90 divided by 3 is 30. So then I'm going to take the square root of both sides. So x is equal to plus or minus the square root of 30. And we would leave it like that. Okay? If you can simplify the radical, you should. Let me see if do I have an example on the next one? I wonder if I do. Like if I had the square root of 27, this can be written as the square root of 9 times the square root of 3, which the square root of 9 is 3, and we would keep the radical. So the square root of that 27 would simplify to the square root of plus or minus 3 radical 3. We'll do more practice with this, but these ones are simplified because there's no perfect squares that go into them. We'll talk about that later. Okay, if you have a square root, if we have part in parentheses, like x minus 9 squared. The part that's squared is already isolated, so what you're going to do is take the square root of that whole thing, and if you take the square root of x minus 9 squared, you're going to be left with just x minus 9. Then we have plus or minus, the square root of 25 is 5. So my solutions are, I have two solutions, okay? I'm going to have x minus 9 equals positive 5, and x minus 9 equals -5. So I need to now solve these separately. So x will equal 14, or x will equal 4. So this involved two steps. Once you took the square root, you had to set up your two solutions by moving what was next to the x over. Okay, we've got one last example. This is a word problem. It says that Miss Perzada is building a retaining wall along one of the long sides of her rectangular garden. So she's got a rectangular garden and she wants to build a retaining wall on one of the sides. Okay? The garden is twice as long as it is wide, and the area is a total of 578 square feet. What will the length of the retaining wall be? Well, the formula we're going to use is we know that length times width gives us area. They're also telling us that if I have the width on one side, the other side is twice as long as that. So it's 2 times W. So to get the area, we know that one of our sides, okay, our length is equal to 2 times W. So I'm going to plug that into L. So I get 2W times W equals A. So 2W squared is equal to, I'm going to plug this area into A because I know the area, 578. Now I want to isolate the squared part, so I'm going to divide both sides by 2. So I get W squared equals, that is 289. I know you guys probably need a calculator for this next step. The square root of 289 is plus or minus 17. Now, let's think about this. I know that W is plus or minus 17. I don't like how they did W here. But can a length be negative? So we've got positive 17 and negative 17. We can't have a length of a wall that's negative 17. So the only one that makes sense is positive 17. So therefore, the length is 2 times 17, which is 34. Okay? And weird.